Now, I want to kick this off by dissecting Table 2 and Table 3 in the chapter. So in USP 800, you've got Table 2, which is specific to non-sterile compounding, and you've got Table 3, which is a couple pages later or sections later in the chapter, that is specific to sterile hazards. Now, the C-PEC, this is called the Containment Primary Engineering Control. That is just a really fancy name for a hood, right? So we may call this a powder hood. We may call it a CVE, a containment ventilated enclosure. We may call it a lot of different things, but the reality is we're going to call that the hood. And then the C-SEC, the secondary engineering control, is just a really cool name for the room itself. So that room in which we compound. But these are the cool acronyms we get to use. So first of all, the hood, we have to externally vent it. That means out of the building, or we have to do redundant HEPA filtered in series. I'm actually going to show you what that means in a future slide. And then I'll even show you what some of these hoods and how we would connect those to the external exhaust system and why and when you would want to do that. Now, externally vented on the room, that means out of the building. Now, in the chapter, it doesn't actually say out of the building. So we kind of have to step back and do a little bit of deductive reasoning and say, what do they mean when they say externally vented? The interpretation is out of the building and at 12 air changes per hour. That means, yes, we're going to be pumping perfectly good air out of the building. Now, does the chapter specifically say that you can recirculate some of the air and you can exhaust some of the air as long as you maintain that negative pressure and those number of air changes per hour? It does not. And this is kind of an edgy part, but if we were to really get the true interpretation, then true interpretation for both Table 2 and Table 3 for the C-SEC is that there's no opportunity of recirculation of air that's been introduced into a hazardous drug room to then get reintroduced back into the air handler. We would call that one pass air in the HVAC world. And then of course, landing this negative pressure between 0.01 to 0.03 inches. Now that, let me go ahead and tell you, 2/100ths of a decimal place of the rooms that have been integrated out there that are already compliant with USP 800, even though the chapter is not compensally applicable right now, those facilities are finding that 2/100ths of a decimal place is not an easy place to land. And again, I don't know how they came up with that number. It is a slight negative pressure. There's nothing about this that is a vacuum whatsoever, but it is a slight negative pressure, but it's also 2/100ths of a decimal place. And we're going to talk about how to land that number as well. So now let's move down to Table 3 with sterile. So you see with sterile, we have to externally vent the primary engineering control. There is not an exclusion for redundant HEPA. So we know that that biological safety cabinet, which is probably what you're using in that scenario, probably an A2 cabinet, or if you're dealing with a lot of volatile chemicals, you're maybe using a B2 cabinet. And then it also calls out the CACI. Now, CACIs are like the glove box, and those would have to be externally vented as well. I'm not a fan of the ergonomics with a glove box, but if you've got one and it works for you, great. I just don't like seeing people struggle when trying to clean the inside of that. So more than likely, as you move forward, you're going to stay probably in the Class 2, A2, or B2 family. Now, the room, again, has to be externally vented. Again, that means one pass air at 30 air changes per hour. Where did they land that number? Well, that number is a good reference back to USP 797. And you'll see as we're talking about USP 800, there are things that are stated in USP 797 that may not be explicitly stated in 800, but we know that there's an interconnectedness of the two chapters. So the 30 air changes per hour actually then qualifies my sterile hazardous buffer room as an ISO 7 because we know that that is the minimum number of air changes and particle counts to maintain ISO 7. And again, we get that 2/100ths of a decimal place right there.